Hello guys, so we're going to do a little intro to our next topic. I hope you had fun with those puzzles yesterday, and I hope they're difficult, but that you were able to figure them out in the end. Anyway, so our first unit is arithmetic, I can't really say it, sorry, sequencing. So in order to do that, we need to understand a couple things before we do that. Alright, so we're going to be going through 3 terms before you do a little worksheet. And the first one is exponential. The next one's going to be linear, and the one after that is going to be rate of change. So let's talk about exponential and what that means. I put exponential growth because that's usually what people think of when they think of exponential. And, let me just zoom out just a smidge. Perfect. Okay, so here's like the mathematical term for exponential growth, a specific way that a quantity may increase or decrease over time. So notice how it's both increase and decrease. That's really important. It's not just a positive growth. Sometimes you have a negative growth. So you always hear that saying, oh, it's growing at an exponential rate. Oh, it's growing exponentially fast or whatever. So all they're saying is that something is growing at a real rapid, super fast pace. And for humans, the main thing that's exponential is actually our population size. So this is actually a little bit inaccurate, but I'm not going to get into that. So from the beginning of time, there's only a very few humans, and over time we increased. And we're exponentially growing. We're growing at a rate that's different each year, that increases each year. There technically should be a dip in here because they did go down around this time for the Black Plague, but we're not going to get into that. So another key thing is exponential growth will usually be a negative or positive number that has been multiplied in a set. I know that might sound weird right now, but we're going to get into a couple examples and hopefully that helps it out. So if you notice between numbers, the difference between that like pattern is multiplication and not just adding, then you're dealing with exponential growth. It's growing at a fast pace. I'll show you some examples, don't worry. I just want you guys to have these definitions in front of you when you do this worksheet. So the next type of growth we're going to look at is linear. Again, this can be positive, negative, but I didn't really set that. So one thing, linear growth means that it grows by the same amount in each step. So the same amount is increasing or the same amount is decreasing. So usually positive and, or negative, don't mind my spelling, a number that is being added or subtracted. Now, if you know, there's one thing you're going to notice, and I will get into this later. I said added or subtracted, but I only said multiplied here. So that is only because when you're dealing with exponential growth, you're going to be multiplying. If you're going down, you're going to be multiplying fractions. But right now, we don't need to get into that. So yeah, you're either multiplying fractions or multiplying whole numbers. So so linear growth is just a nice steady. If you notice, this is a huge dip up. The population grew here. This one is just a nice even line. When you think linear, you always think of, let's just take this off. Think of line. So this creates a line. This is not a line. This is just a nice curve. So that's one way I always remember linear and the difference between them. So linear growth, let's talk about that. Let's say you're buying flooring and you have your square footage for your floor and you have a set price. So if you lose 1,200, if you need like 1,250 square root, oh my gosh, well, give me some time, I got this. If you are selling a house, let's say, there we go, and you have a house that is 1,250 square footage, then you can sell that house at, this is looks like real blurry, but let's just say you'll get 200,000 for it. Now, let's say you lower that to 1,000. This number isn't going to stay the same. It's going to follow a pattern where it's going to change. So let's say we have 1,000, then it's going to get bumped down to 150 and things like that. So linear growth is just a nice, consistent, there's not going to be anything wacky about it. Like this one is not really consistent because it starts increasing, it starts moving around. This one, it just goes up at its normal pace. And lastly, rate of change. So a rate of change is a rate that describes how one quality changes in relation to another. All that means is, let's say we look at this point right here compared to this point. So how did that change? What was the difference? How did I get from this point to this point? And that's going to give me a rate of change. Now here it's going to be quite different. That's why we're going to be going through some examples. So how did I get to this point to this point? All right, now if I get to this point, is it the same? Things like that. And if you're dealing with exponential growth, it should be the same as linear. Okay, so you can pause the video until everyone has this paper in front of them, and then we're gonna go through it. Okay, so arithmetic, can't really say it still, and geometric sequences. So fill in the missing things. So just looking at this, don't focus on the bottom part yet. What would step 4 be? So fill it in, pause the video, give them a couple minutes to fill in step 4, and obviously step 5, step 6. So for me, step 4 would have, I'm going to try to draw it nice. Does it pop up? Oh, I want to use red. Oh, look at how beautiful that, oh, so pretty. Well, didn't want to make that shape. Step 4 would have, so I'm kind of looking at the bottom. I noticed that one just goes on top, and then these are also increasing. This is how I'm figuring it out. You don't have to figure out the same way. And there's only one layer right here. Oh, again, ugly shape. So that's what I think step 4 is going to look like. Do you guys have the same thing as me? What did you put? And why did you pick that? So the reason why I picked this is I noticed that from step 1 to step 2, what happened is I got given a top circle and a bottom circle, and that was my step 2. So I had added 2 pieces. And then from step 2 to step 3, we were also given a bottom and a top circle, which is just another 2 pieces. So I was like, okay, so all I have to do is draw step 3 and then just add a bottom and a top. And that gave me step 4, which is going to be actually, what would step 5 be if I took that into consideration? I'm just going to copy and paste all this so that it looks, oh no, that might actually be harder. So while I'm drawing the answer, you try to figure out what step 5 would be. Again, I'm going to use my method where I draw step 4 and I just add a top and a bottom. So draw step 4. It's not the prettiest, but it worked. That's a square. You know what? Just think of it as a circle. Okay, so that's going to be step 5. So from step 1, let's do some fancy stuff. Okay, from step 1 to step 2, it was an increase of 2. We just added 2. So let's write that in. Oh, look how huge that is. We just added 2 squares. All right. Now this number is either going to change depending on the next thing that we're going to be dealing with. It's either going to change into, oh, maybe it's actually increasing, multiplying, or what if we're multiplying by 2? Because 1 times 2 is still that, even though we're adding. So this is where you don't just stop at the first one. I want you to see the change in step by step for multiple ones. Ooh. Wasn't the prettiest. So from step 2, step 3, did I have a multiplication? Did I have an adding? This step, whenever you do the first one doesn't give it away whether you're either adding or multiplying to get your next number. Either, remember, linear is adding. So right now we think it's linear, but is it really exponential? Ooh, that's the mystery. So from step 2 to step 3, is there any way we could have multiplied a number to get from 3 to 5? Well, no. What we couldn't do is add 2. Plus 2. So right now, since that they're the same, and it wasn't a multiplication, it was an adding, and our first theory was right. Remember I said, oh, we just added 2. I didn't, it could, like I said, it could have been multiplied, it could have still been exponential, but when we went off to step 2 to step 3, it actually showed us, oh, we are adding. We are actually adding. So since we're adding, remember what I said? Since you add something, so the pattern, is linear. How can I tell? Well, because we added, that's not how you spell added 2 circles between each step. And I'm putting brackets, not multiplied, because remember, if it's multiplying, multiply. Oh, you're gonna see my spelling. That's not how you spell it. You guys will know how to spell it. Okay, so that's gonna go, let's see, let's make this nice and pretty. So there we go. Now our rate of change, you could probably guess, actually our rate of change is here. But let's fill this in before we solve the rate of change. You could probably already have it in your mind already. But this part, this is how you're going to fill it out. So you're going to look at your step 1. So step 1, how many numbers of circles are in there? Well, let's check. There's only 1. Okay, so I'm just going to write 1. There we go. Our next step, how many circles are in there? Oh, first, we're on step 2, so we're going to write step 2. And then we're going to write how many circles were in there. There were 3. I'm going to go so forth and so on. 4. Oh, hopefully you guys caught that. It's actually 5. Okay. Let's do this one. We're on step 4. We said that it would be add 2, which is 7. So let's pop that in there. The next one is step 5. And we said step 5 would have 9. And we were lazy to draw up step 6. But we can do it in our head. So step 6, before we drew it, how much would be in there? Well, if you notice, we're just adding 2 between these. So we can assume and know that the rate is a plus 2. Plus 2 between these. Let's see how well I do it. Obviously, you guys are gonna look cleaner than mine, but we noticed that it was a plus 2 change. So our rate of change, because we're gonna use full sentences, change, is plus 2 circles per step. All right, so our rate of change is just changed plus 2 circles per step, and that's actually our units right here. Is just this plus 2 circles. Oh, this plus 2 circles per. Remember, a slash is per step. Okay. So I want you guys to try this one. Try your best. Do what works for you. We did the picture first. But maybe you're like, hey, I like to do the steps first and things like that before you solve this, okay? So I'm going to give you a couple minutes. Pause, okay? Pause the video whenever you feel, and then we're going to get right onto it, okay? So this time we're going to do it different. This one we drew it first. Let's actually do the steps first. So our first step. When you do it's different with everyone, and it's really just personal preference on whichever you like to do. Personally, I'm not a very good drawer, so I like to do the steps first actually. So in step 1 we had 2 blocks. This time obviously we're dealing with blocks. In step 3 we had 1, 2, 3, 4, 5 blocks. And in step 3, oh, did anyone catch this? No one caught this. What are you guys doing? In step 3, we had, let's see, 2, 3, 4, 5, 6, 7, 8. We had 8. Perfect. Now we gotta think. That's our thinking, like Minecraft. What will be our next one? So I really want you to try and think about it before I give the answer. So again, take a little break, and then let's try this out. Okay. So let's do some tests. So from step 1, we had an increase of, we went from 2 to 5. Is there any way that I can multiply 2 by 5? Sorry, is there anything I can multiply 2 by to get 5? Well, no, so it won't be, I don't think it's a multiplication. But can I add anything to 2 to get 5? Well, yeah, I can add 3. So right now, I hope you're thinking, oh, this is, Miss Harper, this is easy peasy. This seems like an exponential. And I mean, oh, hope you caught that. Seems like a linear. But let's check. Remember, always check your step 3. So from 5 to 8, can I multiply any number in order to get, can I multiply 5 by any number in order to get 8? Well, not really. So we know that that it's not multiplication, but can I add 5? Can I add the number to 5 to get 8? Yes. Plus 3. Wow. This one was pretty straightforward. We already realized the pattern so far, plus 3. So with that pattern in mind, what would the next 2 be? Now, I'm real lazy, and I'm not going to draw blocks because it's going to be super hard on PDF. So I want you guys to do it, but I'll give you time to draw, but and then when you're done drawing, if you really want to, you can just do this first. We'll start this. So if we're increasing by 3, then the next one would be 8 plus 3, which is a whopping 11. So then our next one, for step 5, it would be plus 3 from our last step, which is 14. Hopefully you guys are saying it while I'm having a little wait time. Our 6th one, and that one would be plus 17. So it's a consistent growth. We know then that this is a linear. But you guys, before going into this, were like, oh, well, this is going to be obviously exponential. Nah, there ain't no order to this. You're going to actually have to go through it and check. So linear because it consistently, how do we word it? We want to word it because we added 3 squares each time. Okay, now the rate of change is 3 squares per step. So remember, rate of change is this then. Is now how many, like plus 3 squares each step. We didn't go down. All right, now you guys try the rest on your own. You have about a lot left. Oh, okay, the solution of the first one. Okay, so try it. There is a answer key around, so try them. Don't be afraid. Think of is it adding. I know we haven't seen the exponential one, but I kind of want to see how you guys do without seeing one. Okay, so you guys got this.